This is the first of two short videos for just following on from the equations test last week. I've changed the question actually, so if you want to have a play with this before we watch the video, then you're welcome to do so. Otherwise, I've got a question at the end anyway for you to have a go at. Okay, so this question 1 then says, line L has equation y equals 3x plus 7. And our first task is to show that a particular point, minus 3, minus 2, lies on this line. Most of you did that anyway in the actual test. You did it by substituting for x and y, minus 3 and minus 2. And that's fine, that works. It's a bit weird because you end up with sort of minus 2 equaling minus 2 in this case, which is probably okay. An alternative is to just substitute the value of x and hope that you get the right value of y. So we could say if x equals minus 3, then from the equation y must equal 3 times minus 3 plus 7. But very fortunately that comes to minus 2 as required, and that's how you can finish it off. So you can say you got what you wanted as required. Don't put a smiley face if that's what you want. Now, second question then says find an equation of the line perpendicular to line L, and it's got to go through point P. And then it says give your answer in a particular form that we'll look at in a second. And A, B and C have got to be integers. So first of all then, we need a line perpendicular to this line L. Now line L has a gradient of 3, so that's our starting point. So we can say L has a gradient of 3, because that means that we can say the perpendicular gradient will be equal to to find the gradient of the perpendicular, well, you've got to do the negative reciprocal. You've got to do minus 1 divided by 3 in this case, and that is the gradient of the line we're after. So I've underlined it, and that means then that the perpendicular equation, if we're thinking y equals mx plus c, perpendicular equation will look something like y equals, but we know the gradient of the perpendicular is minus a third x plus c. So we know the gradient, we now need to find the intercept. We go a bit. And we find the intercept by substituting in the point. The point was minus 3, 2. So this line has to go through minus 3, 2. So we can say at that particular point, minus 2, sorry. At that particular point, the value of y, minus 2, must equal minus a third times the value of x, which is minus 3, plus c. A bit of work in there. Minus 2 therefore must equal minus a third times minus 3, which is 1. And we get minus 2 equals 1 plus c, which rearranges, take away 1 to get minus 3, being the value of c. Again, underline that. And now we have the equation of the line. We know it's gradient, and we know it's intersect. So we can say, so the equation of the perpendicular is y equals minus a third of x, take away 3. So if you can't see that, because it's off the video, so there we go. So there is perpendicular equation, y equals minus third x minus 3. Now normally at that point we'd stop, but the question asked us to write it in a particular form. So you can see all the variables, everything's on the left hand side, and a and b and c have got to be integers. This way a lot of people missed a mark or two. We're going to need to rearrange this. We're going to need to also get rid of this third. So if we times everything by 3, 3y equals minus x minus 9, and then rearranging that will give us 3y plus x plus 9 equals 0. That is it. Okay, so that's the whole equation. Have a look at it, see how it's all written out, and I've tried to, as I say, keep things fairly sort of logical and structured. It's probably a good idea if you have a go at questions. There's a question here. There's a question somewhere here. Hiding under all those papers. So take a look at that. Press pause on the video and give that a go. I'll put the answer down in a second. So press pause. Dunk. You have to hold. And hopefully, there we go. We're off again. You should have found that point P does indeed lie on that line, and the equation of this line is, I think, 4y minus x plus 31 equals 0. So well done if you got that, and I will see you next week.